Hello and welcome back to module number 6. And today we are going to continue the idea of probability, and we are going to put it in the context of sample. And I will try to spend the most of my time in this video. I will talk about sample procedures and what does it really means. And then I will go over the confidence interval estimation and what does it entail, and I will go further a little bit. However, the majority or the focus of this module is about the sample, because this is where students get confused. And what does it really mean? And what is the probability here? And so I will spend most of my time here. I will not cover every single page in this PowerPoint presentation that you have access to, but instead I will talk about the issue of probability. So let's begin. We talked about probability in the previous two modules. And we talked about what is the probability. Is it known probability? Is it not? And a sample is the idea of taking a portion of the population that is with regard to probability that represent the entire population and count their opinion, count their health, or anything that we want to investigate in order for us to know about the entire population. This is really the essence of the sample and the idea of a good sample versus a bad sample. And we have those two options always available. And now, especially when we are talking about election, we are talking about who, for example, who is going to be the next governor of Florida. And so I took the example of the last 2 years about presidential election, where they did polls and they try to understand why is the polls accurate or not accurate, and how did they fail or not fail with regard to the sample. And this is a good read because it will give you some basic understanding why the sample is a little bit more complex than we think of it, and what can go wrong in a sample, what can go good in a sample, and how do we pursue that in order for us to be successful. So the idea of a sample, I discussed that part in module 1, 2, but it also match up with the ideas of, as I said before, of probability. So the population is considered to be the entire universe, and where the objective of the sample is to capture a small group of subjects that represent accurately the entire universe under investigation. So a sample distribution is created by, and it's also called a sample. Today, we are interested in the sample distribution for the sample means and the sample proportions. So the method that we often employed in this type of statistics is use the rule of probability and the law of the expected value at variance. So the idea here is that we are looking at the sample distribution in order for us to do that. For example, consider the roll of 1 and 2 dice. How did we do that? What we applied, what rule of probability we applied in order for us to find it. So, example, there are 89 students in statistics class. The instructor wants to choose 5 students from the form for a project group. How would he or she pursue? So he has a numbers. Every student, like yourself and like myself, has an ID number. So what he did was given each student the number from 0 to 1 to 89. He chose 5 pairs of random digits from a random number of table, and then if the number is between 900 and 0, if chosen, choose another number. So the 5 students from those groups numbers are matched into groups. So he saw that, or she saw that, in order for us to do that. And so the idea here is that we have two types of sample here. The probability random sample, and again, what type of techniques are we using it? In this case, what I describe here here is a systematic random sample, but we have certified random sample, we have multi-stage sample, and cluster sample, but we also have non-probability sample, and where the researcher or you as a researcher use to more convenient sample, and the idea is the purpose of the sample is more important than the actual procedure. Maybe you do not have the ability to do probability random sample. That can happen. So you need to be very sure of yourself when you are doing a sample. Why are you doing a sample? And can you pursue the sample in that case? So those are the options you have that you are often applied to. So under random sample, we have certified random sample. We divided population to sub population or STARA, and we select a sample random from each group. In cluster sample, we divide the population into subgroups and then select a sample random from those subgroup into a very out of that. So basically, it's another dimension, another step in order for us to be very sure if we are matching what we are looking for. And there is the link systematic sample. We randomly select one of the first key element in the ordered population and then select the key TH element therefore. So every time we select one element and then we go further, and using the subgroup we select those elements too. So for example, divide Florida into counties and take a sample, random sample within each county. Then divide Florida into counties and take a sample random that of 10 counties. So think about Florida. How many counties do we have? Example, in our case, is Hillsborough part of the county that we will take into the sample, random sample that we are counting 10 counties? Again, depends on our procedure. And then divide the city into blocks. Choose a sample random from 10 cities blocks and interview all who live there. So again, choose the entire entry at random from a sample, from a phone book, and then select 50 numbers therefore. So those are 4 techniques that we often encounter when we are doing a sample, and each one of them is valid as long as you follow the rules and follow the procedure those sample consist of. So again, this is type of the methodology that we often encounter. When we are using non-random sample place, and this is when we cannot or unable to do randomization of the subject. So they should not be used statistical calculation or sample procedures into them. So example, convenience is that easily without random selection, or people walking on the street. We select them. The media often use that when they interview people about, for example, what their opinion about the president, or what their opinion about the current governor of Florida, or what they think about the new president of some organization. It is non-random sample because there is no procedure how we apply that. Judgment sample is that the sampler decide who will and will not include in the sample. So we come with a bias inside, and we are declaring it up in front. And all of those plans or non-random sample plans are part of the procedure that you need to declare before you start doing your analysis, before you start analyzing everything. So we have some terminology that entail with that, and when we are talking about the population or probability model, we are talking about normal distribution. That's where we are trying to apply that. The statistics is the random variable calculated from the sample, and it is often called X bar. And those are related but not the same. So, for example, the average age of USF students population is equal to 23.5, but the average age in any sample, X bar, is going to different from what is the population. So again, I want to make sure that you understand the terminology that we are going to use here in order for us to understand the procedure that we're going to take. A sample distribution is numerical descriptive measurements that are called statistics. This is the foundation of statistics. So statistics vary from sample to sample, and it's applied to how do we pick up the random variables into it, and also about this distribution, about sample distribution. In repeated sample, they tell us that the value of the statistic can occur and how often each value occurs in order for us to make sure that our sample is as pure as possible. So again, I'm defining it for you, and the sample distribution is the distribution of values taken from statistics of in all possible samples of the sample size from the same population. And I want to refer back to our notes about probability. Think about when we learn about probability, what is coming up again with regard to the sample, and how do we apply that into our this sample distribution. So the definition: the sample distribution of statistics is the probability distribution for the possible value of the statistics that result when a random sample of size n are repeatedly drawn from the population. So example, if our population is 3, 5, 2, and 1, we draw a sample of size number 3 without a replacement, which means that we are not repeating the same procedure. So it means that in this case, this is what we do. And we cover that in the probability section. So X tag in this case is 10 divided by 3, and this is the procedure that we take. So each value of the X bar is equally likely with the probability of 1 divided by 4. Different measurement of sample distribution, page 127 from my textbook, and in this case the X bar is unbiased estimate of the mu, which means the mean, and this case is how we apply to it with regard to variance, standard deviation, and the proportion in that case. I'm going to outline the example from my textbook in page 128. And again, frequency and relative frequency and the sum of it, and how do we do that? And so the mean of the entire population in this case is equal to mu equal to the xi, which is equal to 0.2, and the variance in this case is 15.448, and the standard deviation in this case is 3.95 and 3.93. And again, make sure that you understand how did I make up those numbers, how did I calculate the standard deviation, and what does it really means. So how large is large? If the sample has a normal distribution, then the sample X hat distribution will be normal no matter what the sample size. And so when the sample population is using systematic, or the distribution become apparently normal for relative small value of n, So when the sample size is q, the sample size must be at least 30 before the sample distribution of x hat becomes a normal distribution. How do we find the probability of sample distribution? We have to follow the score of z, and in this case, this is the formula of the z-score, and in this case, it's x hat minus the mean divided by q divided by the square root of n, and you can find a table in table 3 in my textbook, and in this case the random sample of n equals 16 and the normal distribution of the mu is equal 10 and the q is equal 8. So in this case, this is what we found, and this is how we calculate that. A second example, again, a soda filtering machine is supposed to fill out cans of soda with 12 liquids ounces. Suppose that the fills are actually the normal distribution with a mean of 12.1 and a standard deviation of 0.2. What is the probability the average fill for a 6-pack of soda is less than 12? So again, this is the idea, and this is what we often need to do in order for us to find this distribution and to find what is the z-score in order for us to apply that. So again, I'm going back to the sample distribution, and in this case, I'm going to reintroduce to you the central limit theorem that can be used to calculate the binomial random variable x, where the n is larger, where the mean n multiplied by p and the standard deviation. So the same proportion of the p hat equal to the x divided by n, and in this case is binomial random variable x divided by the n. So in the form of central limit theorem, the p hat will be apparently or approximately normal when a resell mean and the standard deviation. So this is the calculation. This is what I will do in order for us to do that. And again, you have the PowerPoint, so you will be able to read it page by page and go through every element in this procedure. And again, I'm not going to go over every aspect. As I said, my objective in this recording is to talk to you about the higher level of the probability and what is the general properties of a sample distribution of x. So we have 3 rules that needs to be applied when we are talking about sample distribution of x. And if they are applied, we can say that our sample distribution is basically has the idea of this normal distribution. And this is really important, again, with regard to the election, with regard to overall, how do we pursue that? And so the issue here is that is the sample that we are taking is equal to the entire population based on the sample distribution. And in order for us to see if there is a sample distribution, we have to follow those rules, the 4 rules, in order for us to justify. And again, I give you an example in page 131 from my textbook about the example of it. How do we apply that? And as we can see, you have the answer and the procedure and how to calculate the z-score in order for you to fit into it. But as you can see and as you can learn, again, I am sure that you encounter several times mistake or errors that encounter in your calculation. We can also calculate the standard error. And in this case, we need to be aware that we have, if there is a standard error, what is it and how to do that. It's quite simple to do that. The standard error equals, and it is this standard deviation divided by the square root of n, and in this case, this is the result. Again, we can also look at the use of open source R or the RStudio with regard to the central limit theorem in order for us to do that, how to apply to it, and how to qualify to it. So this is a preview of example of it and how to apply that. We estimate the population, and we estimate the idea of it. In order for us to do that, we hope the sample proportion is close to the population. So in this case, we are talking about sample distribution of statistic, and in this case, we are looking at the overall possible sample size of n, and we are using the p hat in order for us to apply to it, and by doing that we are trying to calculate the probability distribution of all possible values of p hat. For example, suppose in this class we have 3 divided by 4 freshmen, and suppose that the samples of 2 students selected with a replacement. Find the sample distribution of p hat. So in this case, we need to calculate the mean, we need to calculate the variance, we need to calculate the standard deviation in order for us to do that. If I will break it down to the calculation itself, this is the breakdown. Each element is being recorded and being presented in order for us to do that. So again, let's x be the number of freshmen in the sample. The probability distribution of x is as follow, and in this case, that's what we do. So the sample size is equal 3, and in this case, we follow those distribution, and we calculate the mean and the standard deviation, and what is it entail in order for us to do that. I also talked about or provide example of survey and how survey actually works and what we are trying to reach when we are doing a survey. And again, this is what we do. In the textbook, I provide example of central limit theorem, and I will illustrate that in R, and where we are going to draw 500 numbers at random distribution where the mean is equal 100 and the standard deviation is equal 0. So again, we start with a sample and population. We will review 5 different methodology, and when we move the sample distribution, I want you to remember that the general properties of the sample distribution rule number 1, 2, 3, and 4, as discussed in slide number 24. So again, this is how we apply that. This is what the statistical confidence means and how to apply to it. And again, this is how we apply in order for us to do that. So again, this is what I try to achieve, and in this example of 12 brown eggs, and again, confidence interval and how we apply to it, what does it really means, and what we call it and how to apply to it in this case. That's it for now. I hope it makes sense. I will try to provide more examples and more coherent procedures with that regard with the R and how to apply to the R. But I will next time, in next module, I will talk more about confidence interval estimation. And I will cover a little bit more about standard error, which I touched, but I did not go into depth. And I'll also talk about estimation of the population, how we compute confidence interval, and what do we do when the population mean is unknown. I hope that this module confused you a little bit more, and I hope it will try to make more sense to tell a story out, or not a story, a narrative, a scientific narrative out of it. Again, please ask questions. Your objective is to makes sense that what we have covered in this module make more sense. Until next time, have fun.